Welcome to another exciting week of network forensics. So, I wanted to see if you wanted to hear a story. Now, a lot of the things, many things we've been looking at so far, we've been trying to get the ultimate answer, like in the payload. For example, in the lab that we worked on in netcat, the most powerful aspect of it was the fact that we could actually see what everyone was talking about. In other words, we could actually see, visualize, and understand the actual payload, as well as just being able to intercept the traffic. Now, those of you that did the netcat assignment properly, and there is one in particular I'm thinking of, and the first letter of the person's name is H, and this person, I'd like to really congratulate them because they, in particular, treated the payload as an actual conversation, and I like that. They were like, "Hey, what time are we going, and where is the location?" So, from a PI, private investigative standpoint, that's a great way to map somebody's goings and comings and goings. So, I would like to say thank you for treating it like a real conversation, and that's where the power of that type of quote unquote surveillance comes from. But what if you have another situation like in the Social Network movie where the character that was playing Mark Zuckerberg was questioned in front of the admin about all of the network activity that was emanating from their station in their dorm room. Now, I'm not saying that they couldn't see all the information. They probably couldn't see any of the conversations because I have to believe it was probably encrypted to an extent, probably not to the same level as is today, because by the very definition, the movie essentially is an origin story of the Facebook application, and how it originated from an actual college student's dorm computer that tells you the power of information, and it tells you that even back then, using the rudimentary tools, they were able to at least uncover the station that all that juice, all that power from which it was coming. So this is a continuation of that. The fact of the matter is, you don't need to see the payload. You don't need to see every single solitary thing about the packet that you've intercepted to really tell a story, okay? And what's missing is always the story, okay? So think of this as a scenario, this very real scenario. Let's say, for example, a suspect data exfiltration after a workstation is infected. So, in other words, a workstation has been infected, and you're trying to do the process of data exfiltration. So, for example, a new university employee, for example, clicks a phishing email attachment by mistake. So we've all been there, right? We've all seen these email attachments that should not be downloaded, and hopefully we have not downloaded them. However, later the security team believes that this attachment, okay, stole some payroll data or some private student data. And because, these, malwares are written so well, you may not have full capture data for that time period. So, applications like the application we're going to talk about, NetFlow, this is where it becomes extremely useful. Now, NetFlow itself is a Cisco centric protocol. Now, Cisco, I always describe Cisco as the Microsoft of network devices. Now, there are many network device companies out there like Nortel, Juniper, okay, and of course Cisco. Now, Cisco, there's nothing special about a Cisco device other than the branding. Some say the power modules are a little bit superior. That being said, nothing much is different. I mean, it's still just an iOS, similarly to how, like, for example, Juniper iOS is. Juniper iOS is more Unix centric because essentially the Juniper iOS is essentially a specialized version of Unix. Okay, whereas Cisco iOS is more like a, I'm gonna say uh, I'm gonna say purposefully spec Linux type of operating system. So they're both kind of borrowing from the Nix world, but Juniper just looks exactly like Unix, and Cisco, it's like it is looks a lot different than a typical Unix, or excuse me, typical Linux operating system. But you can just tell, you can just see some of the commands how they could be like Linux, like because you have commands like IP address space, and then you have then you're supposed to put the IP address. So that's kind of resembles how you would write a Linux command. That being said, NetFlow is a very Cisco esque protocol. And with NetFlow, investigators can see, for example, which internal computer made the suspicious connection, the external IP address that it talked to, what maybe the timing that the connection began, how long it lasted, which protocol and ports were used, and how much data was sent out. So even without seeing the file contents, in the case where an errant email attachment was downloaded, you might discover something like, for example, a faculty computer suddenly started chatting and talking at some external IP that nobody has ever seen before at a very late hour. So it's a faculty computer. So especially when you don't have faculty, remoting in and out. So if there was no such thing as COVID, for example, you wouldn't have a faculty member logging into his private faculty computer, his office station, usually at 2:13. Now, I'm not saying it doesn't happen. You could have a faculty remoting through VPN into his computer for various reasons at such a late hour. Maybe he wants to catch up on some assignments. Maybe there is a student he's working with that is remoting himself, and whatever it is, but it's still rare. Okay, and you can tell that the session, for example, lasted a certain amount of time. So the session lasted 18 minutes. Hundreds of megabytes were transferred outbound, and the same host had repeated short connections every 5 minutes earlier in the day, suggesting beaconing or command and control. So, in other words, we don't have to see the actual conversation. We can take a look at the quote unquote metadata and get the story from that. So, in other words, just like the social engineering movie, they didn't necessarily have to see what was in all that connectivity. They could just see there was a lot of activity going around that computer. So this kind of says that A, the machine could have been compromised. B, sorry about this. B, it communicated with infrastructure developed by a potential nefarious person, and it may have sent stolen data out of the network. So that's in the case of where you could have a faculty member having suspicious activity. Okay. Now, when it comes to the Zuckerberg movie, what they were saying was that, hey, we don't know what is going on. We don't see inside the packet. However, we do see that you have sent a lot of packets, out from this particular computer. So we know you're doing something. We know that you have a web server going, and that is a violation of university policy. So they weren't able to see the packets, but they could tell the story. The story was a likely violation of university policy, because the only way you could have a computer having so many outbound packets, not necessarily inbound, because the way Comcast and Xfinity, for example, the way home networking is set up is you're getting like a gig or half a gig inbound, but outbound it's like an eighth of it. So what these Xfinity servers and WoW servers don't want is they don't want you to have a web server. Same thing with college campuses. They want you to have as much incoming, inbound packets because you're doing research and you're watching YouTube videos, but they don't want to see a lot of outbound packets because the outbound packets are the initializers they're like the client's requests, if you will. So they're asking, well, why are all these requests coming outbound from internal servers? And that must mean that it has a platform that others are drawing from, and that is a specific violation of university policies. So in other words, NetFlow is often used when investigators need to prove that a compromised computer communicated with an outside attacker or transferred an unusual amount of data. Okay? Even though we don't see the internal packets. Now, Cisco NetFlow is huge in university or you could say, in network forensics classes because this is where the network starts, basically delegating its story. So we're telling the story of the packets. Now, as I said, you may not get every payload, but you can see the payload. Okay, you can see the metadata. Okay, so in other words, you can see with the wonders, if you will, of NetFlow, you can see who connected, where they went, how long they stayed, what ports they used, and how much data was moved, which is very powerful. It's quote unquote forensic gold, if you will, because in the real world, attackers try to hide no more traffic, but data flow can still expose scanning, lateral movement, what they call beaconing, and exfiltration. This is why NetFlow matters so much. It shows you how investigators think when the evidence is incomplete, if you will. So you're not just learning the commands, you're learning how to essentially explain and construct or reconstruct the behaviors that created this stream in the first place, because we can detect suspicious patterns and turn raw network activity into basically a narrative for investigation. Okay? So in other words, this NetFlow Cisco technology allows us to capture and summarize network traffic metadata. Okay? It records who we talked to, how long, and what ports they used, and how long the communication lasted, and frankly, how much data was moved. So we're not concerned with what the data was, but if you're seeing large amounts of data moved in a short period of time, okay, that is purposeful. Okay, now there's a lot of things that explain this purposeful data movement, like, for example, when you have data backing up data, when you back up large amounts of data, they call it data replication. Okay, and there's a lot of IBM products. Avamar is a huge IBM product that facilitates data replication, and they do that purposefully to copy data so they have it in more than one place. But if you see this, it might be suspicious, but that's why they call it suspicious and not necessarily something bad, because a lot of companies like Stellantis, Ford, and they all do this. They all do data replication, and I know for a fact Stellantis uses an IBM product called Avamar. But if you call to verify that this station is in fact not part of the data replication architecture, then you have to think that something else, possibly nefarious, is going on, and that's what Cisco NetFlow and I keep on saying Cisco NetFlow, and as a matter of fact, all companies, okay, have their own version of NetFlow. It might be branded as something else, but they could use NetFlow as their backbone and just call it something else, or B, they could have created a very similar product to NetFlow and they just call it something else. So if you're not using Cisco devices, or you're not aware of how maybe you have a third party that operates on top of Cisco devices, it's all the same thing. So what I'm about to teach you can be applied to all aspects of network forensics, regardless of what type of device you're using.